So Numpy stands for numerical Python. It's a scientific computing library that built atop of Python programming language. So the most common way to import NumPy into your Python environment is to use this syntax, import NumPy as NP. So this first portion here, import NumPy, essentially just tells Python to bring the NumPy library into your current environment. Then this next portion as NP just tells Python to give NumPy the alias of NP. So this allows you to use NumPy functions using the dot notation. So simply just type NP dot and then the function name, rather than just typing the full NumPy dot. It's just an efficient way of doing that. And again, it's the recommended practice. So now let's create a one-dimensional array. To do this, we use the NumPy or NP dot, then we import this module array. Now, array is at the core of NumPy, is a data structure that is at the core of NumPy. Okay, now to create a one-dimensional array, we just use a list. The list could have a series of elements or sequence of elements, in this case, integers, separated by a comma. Then we pass it as an argument inside this array module or function. Okay, and then we store it into a variable here, which will become our array object. Once we've created that, let's go ahead. So first of all, we import the package NumPy library, then we run this. You can see now we've just created an array, which is just a bunch of numbers. Now, what makes NumPy very powerful is that you can create 2 to 3 dimensional arrays. So simply here, we can create a nested list. So we can create one element here using square brackets. You can see 1, 2, 3, comma, and then we create another list of elements, 3 elements, and then lastly here, another list of 3 elements. Okay, so we use the square brackets to initialize those nested lists. Okay, and then we close this again inside some square brackets and pass it as an argument inside this array module. So now we've created another array object called B. Okay, and you can see here it's basically just a matrix made up of 3 rows and 3 columns. So essentially here the shape is just 3 by 3. Okay, again, just as lists, you can access the elements of an array using indexing, meaning that we can just using A as our array, we can use the square brackets to access the position element. Already here we can see the ND array with shape 5 equals to that, come up that. But now if we go to A, we can see Python starts at position 0. So we expect here to print 1. Again, you can access, for example, if you're using an multi-dimensional array, for example, B here, so you just tell them you want to access, the first row, and again, the second element. So the first row here, so this is the first row, or 0, so this is 0, then this is 1. And then we start again here, 1, 0, 1, 2. So again, here, the intersection here should be able to print for us 6. So this is what it means, 1, 2. That means from the first row, and then we want to index or extract the second element. So let's again print that, and you can see now we have that. We have extracted that. We've extracted this. Okay. Other useful functions, we can also find the minimum and the maximum value. So we just essentially access these mathematical functions. Just say min and then pass the array, in our case B. That's what we want to use for minimum, max, and sum. So we do that. It's going to find the minimum as 1, max as 9, and 45. Essentially here, we're just adding all these numbers, right? You can see here the minimum is that, the maximum is that, and when we add all this is our sum, becomes 45. You can also calculate the mean and standard deviation, same as this. So we just pass that, we run that, and we can see our minimum, mean is 5, and our standard deviation is 2.51, and so on and so forth. Another useful function is that you can reshape an array. To reshape an array, we use the reshape function here. So let's create an object called E, or rather an array object called E, has the following elements, 6 elements. Now, if we want to reshape these, reshaping just means we want to put this into 2 rows and 3 columns. So we use this reshape and automatically arrange this into a matrix of this dimension, 2 and 3. So we do that, you can see we have 2 rows and 3 columns. So essentially that's a very useful function for manipulating data. So all these examples just shows us how to create an array, and we've performed different mathematical functions, mathematical operations using the Numpy package. Also, we've looked at how to access or extract array elements using indexing. We've also looked at how to find the minimum, maximum, the sum, and also we've calculated the mean and standard deviation and seen how to shape the array. Let's now look at how to add 2 arrays. This is pretty simple. We create 2 arrays. One is called array 1, made up of 5 elements, and array 2 has also 6 elements, 2 different, they're all different elements. So to add them, we just add these 2 arrays, okay, which is just our variable, and store it into another variable we call result, and then print or display the results. So do that, and can see here it just adds them together. 2 plus 1, 3. 3 plus 2, 5, all the way to 6 plus 5. Okay. Again, we can also add the 2 arrays element-wise using the np.add function. So to do that, we just access this function called add, and we pass array 1 separated by a comma, array 1, comma, array 2. We store it into a new array called result. When we do that, you can see again, it just gives us similar results. Okay. Lastly, here you can also use the plus equals to operator to add 2 arrays. So essentially here you can say array 1 plus equals to array 2. So this allows you to do element wise and update array 1 in place. So let's look at the output. You can see here. So all these are different ways of adding elements. So as you can see, Numpy just offers you multiple ways to perform mathematical operations, in this case add. And lastly here we can look at how to do multiplication. So let's say we have 2 arrays A and B, and you can see here we have 2 elements 4 3 and 2 1. Same with this 1 2 and 3 4. Again, to do multiplication here, you can either do print A times B, or if you're using Python 3.5 and higher, you know, this @ symbol is used to do matrix multiplication, or you can actually use np.dot. So let's do that. You can see the outputs are slightly different. Okay, so you can see again here we just created a matrix here. We multiplied them together. And you can see here, this is just matrix multiplication. You can also get the same output using the np.dot. So we do that and pass to those 2 arrays A and B. Then we have something similar to that. All right. And then lastly here, we can also multiply. You can use this double asterisk times 2. This just returns, for example, here, we just multiply this times 2, get the square of each of these elements. So let's look at that. So essentially here, we just say 4 times 4, 16, 3 times 3, 9, and so on and so forth. Same with this, if we say multiply, also find the cube root. It's just the same thing as saying B times B times B. So you can see here, this is 2 times 2 times 2, which is 8. And then this should be just 4 times 4 times 4, which is 64. All right, next we'll look at other functionalities in Numpy.